Today we are going to discuss Wheatstone's bridge, which is one of the application of Kirchhoff's loop rule. What is Wheatstone bridge? If a network of four resistances are connected in this way, these are the four resistances. Let this is P, this is Q, this is R, this is S, and a galvanometer is connected between these two junctions. Suppose this point is A, this is B, this is C, and this is D, and between A and C we connect a cell. Between A and C we connect a cell. This type of network of resistances are used in Wheatstone bridge. Let us consider this cell is supplying a current I to this circuit. Now along the resistance P, let the current is I1. Then along the resistance R, the current must be I minus I1. Because at this point O, the current I divide into two parts. If current I1 is along P, then the current I minus I1 will be along R. Now this current I1 further split at B. Let the current along the galvanometer is Ig, then the current which is along Q must be I1 minus Ig. Now along BD the current is Ig, along AD the current is I minus I1. So the current which is flowing across S is I minus I1 plus Ig. Now at C point, the current which is coming along BC and the current which is coming through DC will be added up at this point C, and then let us see what current we get. I1 minus Ig plus I minus I1 plus Ig, that result current I. It means through the junction C current I is coming out. So the amount of current entering the loop is equal to amount of current leaving the loop. This condition must be satisfied. Balanced Wheatstone bridge is a bridge in which no current flow through BD, means in this case Ig must be equal to 0, or you can say VB equal to VD. If the potential of point B and potential of point D both are equal, then the potential difference between B and D will be 0. And in that case, no current will flow along BD, and such type of Wheatstone bridge is called balanced Wheatstone bridge. Now, let us find out the condition of a balanced Wheatstone bridge. Conditions for the Wheatstone bridge to be balanced, we are trying to find out. Consider the loop. First, let us consider the loop A, B, D, A. A, B, D, A, this loop we are considering. In this loop, we can see VA minus VB equal to I1P, VB minus VD equal to Ig into G. We are considering that capital G is the resistance of the galvanometer, and VD minus VA, it must be minus I minus I1 into R, because the arrowhead is along AD and we need VD minus VA, So this potential difference must be negative because the potential of point A is higher than D and we are calculating VD minus VA, that is lower value of potential minus higher value of potential. That's why the result is negative. If we add these three equations, then we get left side 0 equal to I1P plus Ig into G minus I minus I1 into R. So we get I1P plus Ig into G minus I minus I1 into R equal to 0. Now if you consider the condition of a balanced Wheatstone bridge, then Ig must be taken as 0. So taking Ig equal to 0 for a balanced bridge, what we can write? I1P minus I minus I1 into R equal to 0, or we are getting I1P equal to I minus I1 into R. This is equation 1. Now, let us consider the other loop. Now, we are going to consider other loop. This is the equation we derived by solving the first loop A, B, D, A. Now, we consider the second loop. Which loop we are going to consider now? B, C, D, B. Loop B, C, D, B. In the loop B, C, D, B, we can write VB minus VC equal to I1 minus Ig into Q. Second equation, VC minus VD equal to minus I minus I1 plus Ig into S, and VD minus VB equal to minus Ig into G, considering capital G as the resistance of the galvanometer. Since Ig equal to 0 for a balanced Wheatstone bridge. Okay, this condition we will consider later on. First, let us write the equation. So, in this equation, VB, VD, VC cancel out. So, 0 equal to I1 minus Ig into Q minus I minus I1 plus Ig into S minus Ig into G equal to 0. Now, for a balanced Wheatstone bridge, we know Ig equal to 0. If Ig equal to 0 we put, then we get I1Q minus I minus I1 into S equal to 0. That result, I1Q equal to I minus I1 into S. This is equation 2. Now, if we divide these two equations, equation 1 and equation 2, then what we get? Dividing equation 1 and equation 2, we get equation 1 divided by equation 2, we get I1P by I1Q equal to I minus I1 into R divided by I minus I1 into S. This cancel out, so we get P by Q equal to R by S. This is the condition of a balanced Wheatstone bridge. So the Wheatstone bridge can be considered as balanced Wheatstone bridge when the ratio P by Q equal to R by S. In that case, no current will flow along the direction BD, and that is possible only when P by Q equal to R by S. And in that case, we can say that the resistance P and Q are connected in series and resistance R and S are connected in series, and combination of P and Q and combination of R and S, they are connected in parallel, because the middle branch is now of no use because no current is flowing along BT. So these two are in series, these two are in series, and this group are in parallel. Let us discuss meter bridge. This meter bridge is an apparatus which is used to determine the unknown resistance. Let the unknown resistance be X. In the meter bridge arrangement, this is a brass strip. These are the brass strips, two L-shaped and one rectangular brass strip. And between A and C, 100 meter long uniform resistance wire is stretched, and 1 meter scale is attached here. This is 1 meter scale which is fixed here to measure the length L, and so on. Measure the length L here. Now, between A and B, we connect the resistance box, and we can introduce the resistance of any value through this resistance box. And the unknown resistance is connected between B and C. This point is A, it is a strip of negligible resistance. So here you can write A. This point is C, it is also of negligible resistance. So here I am writing C. Between C and A, we are connecting a cell. Now, its equivalent diagram is shown over here. You can see between A and B, the resistance box, let the resistance R is connected. Between B and C, X is connected. Now, you have to fix the resistance of the resistance box in such a way that for a particular length L, no deflection is found in galvanometer. Suppose this resistance you have fixed as R, and after switching on the circuit, this is the jockey, and when the jockey is slided on the wire and when it is reaching to the point J, let the galvanometer is showing null deflection. So when the galvanometer is showing null deflection means along BD no current is flowing, along BD no current is flowing, and we know that is called a balanced Wheatstone bridge. And when the bridge is balanced, then we know that the resistance of the arm AB by resistance of the arm BC equal to resistance of the arm AD by resistance of the arm DC. We know for balanced Wheatstone bridge, resistance of the arm AB by resistance of the arm BC equal to resistance of the arm AD by resistance of the arm DC. This is the condition of a balanced Wheatstone bridge. Now, at length L, if we get the bridge as a balanced bridge, then what is the resistance of the length L? Let rho is the resistance per unit length. Let rho is the resistance per unit length of wire AC. Then what is the resistance of the length AJ of the wire? That must be rho into L. And what is the resistance of JC? That will be 100 minus L into rho, because we are considering the length of AC as 100 centimeter. Now, according to the condition of a balanced Wheatstone bridge, this RAD is same as RAJ, and RDC is same as RJC. So, the bridge is balanced because the galvanometer is showing null deflection when the jockey is at point, jockey J is at point D. So, we can write that resistance of AB, which is R, by resistance of BC, which is X, equal to resistance of AD or AJ, that is equal to rho L, by resistance of DC or resistance of JC, which is 100 minus L into rho. Cancel rho, so it is L divided by 100 minus L. So we can write XL equal to, we can write from this equation, XL equal to R into 100 minus L. So X equal to R into 100 minus L divided by L. If we know the resistance R of the resistance box, and if we know the length L, then putting all these values in the right hand side of this equation, X can be determined.